Welcome back to another video on the channel. In today's video we're going to be taking a look at question 6 from the 2020 Chemistry External Exam for paper 1. Yes. Now you would have noticed with all the videos I've started splitting up each question into an individual video. That way I can go into a bit more depth on each question, and it also gives you guys a bit more variety in terms of what you need help with. Now, if you need the full exam video, the link is still up on YouTube. The link is in the description below. If you want a chemistry external exam bundle pack, the link is in the description below, so get your download quick. But otherwise, let's just get straight into question 6. So 6, calculate the cell potential produced by zinc and copper's galvanic cell under standard conditions. Okay, so we won't be able to do this question unless we have our table with us in terms of chemistry. So on your formula sheet, you get given this table here with all the E naughts. Now they're all written in terms of like each of them being under reduction because they're all gaining electrons. However, in this situation here, we need to work out basically which one would be doing reduction and which one would be oxidizing. So at the top of the table, things like to oxidize very well. Okay, so these are very strong reducing agents. They like to lose their electrons. Anything further down the table likes to do reduction. Okay, these ones are good oxidizing agents. So strong oxidizing agents at the bottom, weak oxidizing agents are at the top. So here we want to know where these guys are positioned. Now notice the ions here. So here we're looking for copper 2+ and just zinc 2+ present in our table. So if we look at our table here, I believe copper, there are two types of copper. So there's a single one there. You want this one here. Okay, because that's got the 2+. Then you want the zinc 2+ here, so we'll write both of those equations just now. So zinc 2+ plus 2 electrons produces zinc solid and has a E naught of negative 0.76. Then you've got the copper, so Cu2+ plus 2 electrons produces copper solid and has an E naught of 0.34. Now a lot of people would make the mistake and just add these two equations together. However, that's not the case. We need to write it as a full equation and then work out what the E naught would be. So in this case here, because zinc is higher up on the table, it will lose its electrons before anything over copper. Okay, so in this case here, we need to write it as if it was losing electrons. At the moment, it's written as if it's gaining electrons. So you need to flip the equation the other way around with the first one, which means you have to flip the E naught because the voltage is going the other way. So here you write it as zinc solid turning into the ion plus 2 electrons. So this is now showing it's losing it. And then the E naught becomes positive. Then what you would do, if this was like a short response question, is you would add both equations together and you should be able to cancel out electrons. Now even if you had to multiply things to get electrons, the voltages will stay the same. So if you add these guys together, if I add this with that, I'll have zinc solid plus copper 2+ plus 2 electrons produce this plus that. Zinc 2+ plus 2 electrons plus copper solid, and the E naught would be 0.76 plus 0.34. Just rub this guy out now. Now what you should notice if you've done it correctly, if it was like a full equation one, now here we just care about the E naught in this question, but here the electrons should cancel out. So you'd be left with this as like a quote-unquote full equation, and then whatever this adds up into. So here this will give you, I believe, 1.1. So that's your E naught for this reaction here. So the correct answer here is going to be D, positive, okay, because it's a galvanic cell. Anyway, if you have any questions about this one here, leave something in the comments. If you want the chemistry external exam bundle pack, the link is in the description below. And then if you want the full exam video, link is also in the description below. So I'll see you in the next video.